Hello everyone, welcome to my channel. Myself Vignesh Anand. In this video, we are going to see about the AC motors and how they are constructed and their types. So, coming up to the AC motors, the AC motors that converts the alternating current into a mechanical energy or a power by using a electromagnetic induction phenomenon. So, it is just a electrical operated device which converts a electrical energy into a mechanical energy. As you know that motors are divided into a AC and DC. In this topic we are going to see about the AC motors and their main constructions. In construction wise, they are having a two main parts as a stator and rotor, and the stator is a static part and the rotor is your rotating part. So these both are separated by a small air gap of a zero point 0.4 mm to 4 mm depending on the rating of these motors. So the main constructor part is your stator, static part, and the rotor, rotating part. Next is just a small briefing. The stator and the rotor, which produces a rotating magnetic field, and the magnetic, which means the winding of the stator that creates the rotating field, is created by the alternating current, which we are giving as a supply. Then in a AC motor, the winding serves as a armature winding and the field winding. So there are two types of winding, armature and field winding. When stator is connected to the AC supply, so a flux and air gap in the flux is produced, and the rotating the flux at a fixed synchronous speed, which produces voltages in the stator and rotor windings. Then coming up to the construction of AC motors mainly carried by two major parts as a stator and rotor. Stator is your stationary part and rotor is your rotating part. The stationary part consists of a coil converting its entire inner peripheral, and on passing an electric current, in this winding the electromagnetic field, which means uh, the coil get energized and forms a electromagnetic field and create a poles of alternating polarities. Then rotors. A rotor is a AC motor, either uses a permanent magnet or a core made up of a thin laminated shields steel as a rotor. The latter uses a conductor bars instead of coils of wire as a conductor. So this is your rotor constructions. Then other parts, bearing. So a shaft holds the rotating part of the motor. The bearing or between them allows free movement of the rotor. So as you know that rotor which rotates and forms the uh, acceleration or a torque. So for that, the bearing which holds that rotating parts and makes a free movement. Then frame or yoke, it is your outer covering of your motor, which covers the whole stationary and rotating parts, which means your stator and rotors, and protect from the external environmental factors. So this is how the motor looks. So the outer covering, which is your yoke or frames, which separates the stationary and rotating parts from the external environment and protects from the other hazardous factors. Then inside part is your bearing, which consists of a bearings and stator and rotors. So the stator in the sense stator winding and rotors, uh, rotor in the sense the rotatory portions of bearings and drive shafts, and uh, the rotating parts, which means the rotor, which additionally carries fans, so that the fan blades are being connected in the rotor parts in order to reduce the heat of your motor. So this is the part wise constructions of your AC motor. So the wiring covers, which means your terminal portion, and then motor frame, which means your yoke end to uh, to protect the motors in which the frames are being constructed in the outside. Then the stator which carries with the stationary parts and stationary windings, which means your stator windings. Then rotor uh, which has a rotating parts and fan blades in order to reduce the heat of these rotating parts. Then the bearing which is connected with the external equipment for the rotations. And last is your covers, which means your end belts. So this is your full terminals or parts of your AC motor. Just you can go through it: the fan covers, fans, bearings, terminal boxes, stator windings, stator shafts, V-ring slides, then truck plugs, end shields, rotors, frames, and nameplate, which means your nameplate specifications. These all been constructed and forms together as a AC motor. Just you can have a look into it. Next is your principle of working. So now we are considering the rotor portion as a permanent magnet for the principal working, and we have different types of rotor also. In here we are using the permanent magnet as a constructions. The rotor moves freely between two electromagnetic stator poles, which is your pole A and pole B, with a small air gap between them. The electromagnetic connects directly to the AC supply. Then on giving a AC supply, the electromagnet get energized and forms a magnetic pole. Just a small view. This is your AC motor constructions of permanent magnet. So as I said, pole A and pole B is in your side of your permanent magnet rotors, and whenever the AC supply is given to the pole A and pole B, automatically your rotor will rotate as per the uh, magnetic field attraction and repulsion, because as per the electromagnetic inductions principle, the permanent magnet will act whenever the AC supply is given, because the AC supply is having a frequency of 50 hertz, and it is forms a sinusoidal wave, which means there will be two half per as a positive cycle and a negative cycle for a full rotation, which means full completion. So there will be a changes in your rotor and all. This your case study. As I said, it is having a two half of your cycle as per the waves formed in a AC supply. During a positive half of the cycle, the pole A attains a north pole polarity and pole B attains a south pole polarity. Now, according to the law of magnetism, so now the unliking poles, which means your north and south pole will get attracted, and so the pole A attains, which means attracts the south pole of your rotor. This is how the rotation starts, and in a second negative cycle, second half, the polarity of your AC supply get reversed, and hence the polarity of the poles will also get reversed. So now the pole A attains a south pole polarity and pole B attains a north pole polarity. In this situation, the like poles face each other. So automatically like poles face each other means your repulsion gets started, and it will tries to deflect the rotor from the position. As the rotor get deflected, then automatically it will move towards the attractive side, and hence the pole A attracts the north pole of your rotor now, because in the second half the polarities get reversed. So this is how the rotations carried out in your AC motor. Next, coming up to the advantage, the main advantage is that low startup power demand, that also protects the component of on the receiving end. Then second thing is your controllable starting current level and accelerations. And next is your VFD, variable frequency types, and additional controls can be carried out in your AC motors. Next, which means the variable frequency drive, which controls the speed and the torque at the different stage of use. Next, high durability and longer life. Next, capability for a multi-phase configurations, which means a single phase AC motor and three phase AC motors also been possible, and it is in implementations also. Then applications, it is used in your compressor drives and other systems. Then for a converter systems, then for fans and air conditioners, then for hydraulic and irrigation pumps, then for transportation equipment. These are all the some good examples of your applications. Then coming up to the main types, there are different types of AC motor. According to their principle of operation, they are mainly classified into three types: synchronous motor, asynchronous motor, and commutator motors. Synchronous motor in the sense that motor which runs on your synchronous speed with the control of speed. So the synchronous motor in the sense the speed can be controlled and varied according to their need, but anyhow it will never deflect with their load, which means with their varying loads. The synchronous motor is subdivided into a hysteresis motor and non-excited synchronous motor, then reluctance motor and permanent magnet motors. Then asynchronous motor is your second type of motor, which means your uh, motor which never runs in a synchronous speed or will never attains the maximum rotations or maximum speed. The synchronous asynchronous motor is subdivided into three types: induction motor, squirrel cage motor, and slip ring motors. Then commutator motor. Commutator motor is subdivided into a series motor, compensator motor, shunt motor, repulsion induction, and repulsion start induction motors. Mainly, this induction motor is commonly used in most of the equipments. This induction motor is subdivided into two types as a single phase and three phase. Then further it is subdivided into a capacitor start, capacitor run and start, like kind of different types as per the usage. Next is classified according to their speed of operation as a three types: constant speed, variable speed, and adjustable speed. Then classification according to their structural features: open type motors, closed type motor, semi enclosed motor, ventilated motors, pipe ventilated, and reverted frame eye motors. Then motor classification according to their type of current as a single phase and a three phase motors. So these are all the types of AC motors. Next video, coming up to video, we will explain each types for each video. Hope you understand. I think so. Have a nice day. Nandri Vanakkam.